Peace be upon you all, and welcome to TRONICS. My name is Fatima Garba Yusuf, and in this video I'm going to walk you through Jamb past questions and answers for chemistry of the year 2019. We'll notice that as this is these are past questions from an actual Jamb exams. You'll notice that the questions range from different topics. You'll see that they cut across different topics, and the key here is trying to help you get an idea of how Jamb questions are set, and for you to actually go and take a look at some of the topics you might have rushed through or you're not really clear on, so that you will not have problems while answering your own Jamb exam. It doesn't really matter whether these questions come back in your exam or they don't. The important thing is for you to try to be familiar with the topics and the questions and how the questions are being set, so that you will be able to navigate your way and answer the questions during your own exams. So here we go. The first question here says, pollution of water by crude oil can lead to A decrease in carbon dioxide content, B an increase in oxygen content, C a decrease in oxygen content, and D an increase in growth of aquatic animals. Actually, when water is being polluted by crude oil, this reduces the oxygen content and even leads to the death of aquatic animals. So here we can see that our answer is C, a decrease in oxygen content. The next we have question 2, which says, which of the following pollutants will lead to the depletion of ozone layer? A chlorofluorocarbon, B carbon dioxide, C hydrogen sulphide, or D sulfur dioxide. So actually, chlorofluorocarbons or CFCs destroy the Earth's protective ozone layer, and this ozone layer, which shields the Earth from harmful UV rays, when depleted actually leads to a rise in the global temperature, also called global warming. So we can say that our answer here is A, chlorofluorocarbon. Next we have question 3, which says oxygen in air can be removed using A, lime water, B, caustic soda solution, C, pyrogallo solution, and D, slaked lime. The answer here is C, pyrogallo solution, because one of its many applications is removal of oxygen from air. Then question 4 says, calculate the pH of a solution of 0.0001 mole per dm cube hydrochloric acid. To solve this question, we need to do a bit of calculation, which is really why you need to go along with your pencil and perhaps a plain sheet of paper in case you're not given paper during your exam, so that you might be able to solve questions like this. Even though you have a small calculator on the screen, there are some questions that need you to solve on paper or sketch on paper. So here we go with the brief solution. You were told we have 0.0001 mole per dm cube of hydrochloric acid. We're asked to find its pH. Now pH is a measure of the acidity of the basicity, or it's a measure of the acidity or the alkalinity of our solution. To also calculate the pH of this, we need to calculate using this formula, pH equal to negative logarithm of our hydrogen ion concentration. And we can see that we have already been given our concentration here. So to calculate the pH, we'll say minus log of 0.0001. This will translate to minus log of 10 raised to the power of minus 4. And as you can take this minus 4 outward, this minus 4 multiplied by the negative sign here will give you positive 4. So it will be 4 log 10. Since this is log 10 to base 10, it will turn to 1. So we'll have 4 times 1 giving 4. So from our options, we have B to be 4, so your answer here is B. Now question 5 says, which of the following drying agents is not suitable for drying hydrogen sulfide? A. Calcium oxide, B. P4O10, C. Calcium chloride, and D. H2SO4. So the answer to this question is H2SO4, that's tetroxosulfate 6 acid, because when you react hydrogen tetroxosulfate 6 acid with hydrogen sulfide, it leads to the production of sulfur. So the answer here is D. Then question 6 says, the radioisotope used in industrial radiography for the rapid checking of faults in welds casting is A. cobalt 60, B. iodine 131, C. carbon 14, and D. phosphorus 32. The answer here is cobalt 60, as one of its many applications is checking for faults, and it has a characteristic half-life. So the answer here is A. cobalt 60. Question 7 says, how many unpaired electrons are in the p orbitals of a fluorine atom? We have A, 1, B, 2, C, 3, and D, 0. To better answer this question, there's need for us to actually see how the arrangement of the electrons in the orbitals of a fluorine atom are. First, you can recall that the fluorine element has an atomic number of 9. Meaning it has 9 protons, and its neutral atom also has 9 electrons. So writing its electronic configuration, we have 1s2, 2s2, and 2p5. So when you add 2, 2, and 5, it will give you 9. So when you draw this out, you have 2. There are no unpaired electrons here. Here also we have 2. 1 here, 1 here. While for this, in the p orbital, there are 3 units. We have 1, 2, 3. They will enter singly before doubling up. 4, 5. So we are left with just 1 unpaired electron. Therefore, our answer will be A, 1. The next question is question 8, which says the radioactive emission with the least ionization power is A. Gamma rays, B. Beta ray particles, C. Alpha particles, and D. X-rays. The answer to this is gamma rays, because gamma rays have the greatest penetration power and also the least ionization power. So our answer here is A. Next is question 9, which says the shape of the carbon 4 oxide molecule is A. Angular, B. Tetrahedral, C. Pyramidal, and D. Linear. Our answer here is D. Linear, because carbon 4 oxide molecule has 2 oxygen molecules side by side and it looks linear. So our answer here is D. The next is question 10, which says which of the following molecules is held together by hydrogen bond? A. H2SO4, B. hydrogen fluoride, C. methane, and D. HBr, hydrogen bromide. Our answer here is hydrogen fluoride, as it's one of the most common molecules which is held by hydrogen bond due to the reactivity of fluorine and other characteristics. And next we have question 11, which says the monomer of natural rubber is A. 2-methyl-buta-1,3-diene, B. 1-butene-triene, C. buta-1,3-diene, and D. 2-chloro-buta-1,3-diene. So actually the monomer of natural rubber is mostly known by its common name, which is isoprene, but its actual name is 2-methyl-buta-1,3-diene. So our answer here is A. Next is question 12, which says for the general equation of the nature xp plus yq given MR+ns, where x, y, m, and n are actually numbers, the expression for equilibrium constant is, you were given a range of options here. So actually when you're writing the equilibrium constant, the way you do it is you take the products and you use the coefficients, that's these numerical values, as the exponents of those quantities. So here now we'll have r raised to the power of m, or can put m as the exponent of r while keeping your r in square brackets. Likewise, your s in square brackets with n as an exponent divided by p in square brackets with x as an exponent, and q in square brackets with y as an exponent. That's, you can simply say we are having the products as the numerators and the reactants as the denominators. So our answer here is D. Next is question 13, which says what volume of 0.1 molar sodium trihexynitrate 5 solution contains 5 grams of solute. You're also given the atomic masses of sodium, nitrogen, and oxygen. Now actually this is like indirectly giving you the solubility of sodium trihexynitrate 5 in this solution, and you're also given its mass. Then you're asked to calculate the volume. So to do this, we are just going to use our formula for solubility and then make volume the subject of the formula. The formula for solubility is, if you take S as your solubility, it's going to be the number of moles divided by your volume. So here we don't have the number of moles, we don't have the volume, but we have our reacting mass, or shall I say the mass of the solutes, as 5 grams, and we can also calculate our molar mass. But then we have to write the expression for sodium trihexynitrate 5 acid, sodium trihexynitrate 5, and that's NaNO3. Then we use this to calculate our M, that's our molar mass. So we have sodium as 23, then plus nitrogen as 14 and oxygen as 16 in 3 places. So this will give us 23 plus 14 plus 48, which will give us 85 grams per mole. With this, we can calculate our number of moles, which is equal to the mass divided by the molar mass. So we have 5 divided by 85. And you can divide this to be 1 over 17. So we'll now say, okay, since we have our number of moles to be 1 over 17, we can take V to be the subject of the formula by taking V to this side and taking S here. So we have V is equal to N divided by S. So we have 1 over 17 times your solubility, which was given as 0.1. So 0.1 m is the same thing as 0.1 mole per liter. So this is implying that our answer here, the volume here, since we have this as the units of the denominator is mole per liter, this mole cancel this mole, giving us per liter 1 over liter, and the inverse of this will just give you your V in liters. So here when you divide this, it is going to be 1 divided by 1.7, which will give you 0.588 liters. So you go back to your options and you see that C is the one that gives you your answer as 0.588 liters. Therefore, C is your answer. Next is question 14, which says which of the following halogens is the most reactive? Among our options, we have A, chlorine, B, iodine, C, bromine, and D, fluorine. Your answer here is fluorine because it has the smallest radius and it's the most electronegative among them. Therefore, it's the most reactive. So our answer here is D. Then next we have question 15, which says a gas that forms a black precipitate with lead 2 ethanoate is A, chlorine, B, ammonia, C, hydrogen, and D, hydrogen sulphide. And your answer is hydrogen sulphide, and that's why you need to know the characteristics of your various compounds, especially the common ones, your non-metals, your metals, your acids, your bases, and so on and so forth, as well as the characteristics of the gases they evolve in certain conditions. Then next you have next is question 16, which says the common ore of iron is A. Bauxites, B. Galena, C. Cassiterite, and D. Magnetite. The answer is D. Magnetite is the most abundant ore of iron available. And then question 17 says the difference between colloids and suspensions is brought out clearly by the fact that while colloids A do not scatter light, suspensions do. B can be separated by filtration, suspension cannot be separated. C can be separated by a membrane, suspension cannot. D do not settle out on standing while suspension do. The key to answering questions like this is knowing the characteristics of the things you're actually asked to differentiate. Now, the characteristics of colloids include they have the ability to scatter light, so you can see that A is not the answer because this is supposed to be a continuation of having colloids. Colloids do not scatter light, that's what A said, so our answer is not A. Then one of the characteristics of colloids is that they cannot be separated by filtration while suspensions can, so you can see that B is also not our answer. Among these options, the answer is colloids do not settle out on standing while suspensions do. So our answer is D. Next is question 19, which says which of the following pollutants is associated with brain damage? We have A. Carbon 2 oxide, that's carbon monoxide. B. Reactive fallout. C. Biodegradable waste. And D. Sulfur 4 oxide. Now, one of the side effects of carbon monoxide is that it actually reacts with hemoglobin in red blood cells and causes brain damage. So our answer here is A. Carbon monoxide. Next is question 19, which says which of the following will produce a solution with pH less than 7 at equivalent points? To know this, you have to know what having a pH less than 7 implies. What it actually implies is that the solution is acidic. So you should be on the lookout of having a solution where you have a strong acid but a weak base. Now here we have, in A we have a strong base, so it's not our answer. In B we have a strong acid and a strong base, and they'll just neutralize each other. While for C we have a strong acid and a weak base, so it's our answer because even D has just a strong base but a weak acid. So our answer is C, HCl plus magnesium hydroxide. The next question is question 20, which says the number of hydroconium ions produced by one molecule of an acid in aqueous solution is its A. Basicity, B. Acid strength, C. pH, and D. concentration. Our answer is basicity, as the definition of basicity is the number of hydroconium ions produced by a molecule of an acid in aqueous solution. Next is question 21, which says an effect of thermal pollution on water bodies is that the A. volume of water reduces, B. volume of chemical waste increases, C. level of oxides of nitrogen increases, D. level of oxygen reduces. And our answer is the level of dissolved oxygen level reduces. So our answer is D. Then question 22 says which of the following is a deliquescent compound? A deliquescent compound is one which absorbs moisture from the atmosphere and even turns to a solution. So our options are A. sodium trihydrocarbonate, B. calcium chloride, C. copper oxide, and D. sodium trihydrocarbonate along with 10 molecules of water. Our answer is B. calcium chloride, which actually absorbs enough moisture from air to form solution. So our answer is B. Next question is question 23. It says the two ions responsible for hardness in water are A. calcium and or magnesium ion, B. potassium and or magnesium. We have C showing calcium or lithium, and D calcium and sodium. So the ions whose presence is responsible for hardness of water are calcium and magnesium ion. So our answer here is A. Then question 24 says the function of zinc electrode. The function of zinc electrode in a galvanic cell is that its A undergoes reduction, B serves as the positive electrode, C produces electrons, and D uses up electrons. Now answer is it produces electrons. This is because in a galvanic cell, the zinc electrode actually acts as the anode and hence supplies electrons. Then the next question is question 25, which says consider the equation below. We have this equation showing chromium oxide and ion 2 with hydrogen given chromium atom or chromium cation and ion 3 plus water. So we're asked to find the oxidation number of chromium, or the change in the oxidation number of chromium from the left hand side to the right hand side. To do this, we need to consider these two compounds, the chromium oxide and the chromium cation on the right hand side. So we'll do a bit of calculation. On the left hand side we have this, while on the right hand side we have so we're asked to account for the change in the oxidation number of chromium. To do that, we simply find the oxidation number of chromium on the left hand side and the oxidation number of chromium on the right hand side. Obviously, the oxidation number of chromium on the right hand side, since it has its simply a cation here, it's not linked with other elements. We can say that this number here, it's indicating its oxidation number, that's 3 plus, or should I say plus 3. While on the left hand side we have to calculate it by balancing up and equating to -2. So let's say the oxidation number here is C for chromium, while for oxygen it's always -2, and since it's in 7 places we have 7 times -2, then equal to this -2 at the top here. So we have C plus this will give -14 equal to -2. When you take this to the right hand side, it will be C is equal to 14 minus 2, that's 12. But then this C is actually in 2 places. So when you find your answer here, you divide by 2. That will give you the actual oxidation number of chromium. So ON is equal to your C divided by 2, since this is in 2 places, that's 12 divided by 2, and to give you +6. So this is implying that the change of oxidation number of chromium is from +6 to +3. That means it was reduced. From the options we have, there's +6 to +3. So our answer is B. Then the next question says, the condition required for corrosion to take place is the presence of A. Water and carbon dioxide, B. Water, carbon dioxide and oxygen, C. Oxygen and carbon dioxide, then D. Water and oxygen. So this is question 26, and the previous one is supposed to be question 25. Apologies for the mix-up. Anyway, the answer to this question is D. Water and oxygen. Next is question 27, which says the alkanol obtained from the production of soap is A. propanol, B. ethanol, C. glycerol, and D. methanol. The answer here is glycerol, as it's given as a byproduct of the saponification process. Next is question 28, which says the process of converting starch to ethanol is A. cracking, B. distillation, C. fermentation, or D. oxidation. Cracking is involved in the petroleum industry, breaking down of hydrocarbons. Distillation is involved in the separation of hydrocarbons. Oxidation is the addition of oxygen, while fermentation is actually what involves the process of converting starch to ethanol. So our answer is C. fermentation. Then next we have question 30, which says in the equation above, y is, here we are going to look for what y represents. To do that, we simply need to balance up the ions and the atoms we have here. So we have one atom of manganese and it's balanced up here. We have 4 of oxygen here and it's already balanced up with this 4 of oxygen here from water. Then we also have 5 of iron here, while for hydrogen it's not balanced. Since we have all other elements balanced, excluding hydrogen, we simply find the number of hydrogen here, and that will automatically give us the number of hydrogen on the left hand side. So on the right hand side, we have 4 times 2, that's 8 of hydrogen. Therefore, Y represents 8 of hydrogen. So our answer is D. Then next is question 30, which says given that M is the mass of a substance deposited during electrolysis and Q is the quantity of electricity consumed, then Faraday's first law can be written as dash, and we're given an answer key that E is representing the electrochemical equivalence. This is because sometimes when you look for the expression of the Faraday's law, you notice that you are given your M in terms of Z or something like that. So usually when you check it out, you find that your M is equal to ZQ, but then Z is also the expression of the electrochemical equivalent. So since they just changed the letter here, you can say that your answer is B, M is equal to EQ. Then next is question 31, which says to a solution of an unknown compound, a little dilute tetraoxysulfate 6 acid was added with some freshly prepared iron 2 tetraoxysulfate 6 solution. The brown ring observed after the addition of a stream of concentrated tetraoxysulfate 6 acid confirmed the presence of A. trioxysulfate, B. trioxynitrate, C. trioxycarbonate, or D. chlorine ion. All of these are ions. So when you know your various anions, your cations, your metals, your non-metals, you also know the various reactions that occur when certain acids or certain compounds are mixed or reacted with certain substances. So in this case, actually it's the trioxynitrate ion that results in a brown ring after the addition of tetraoxysulfate 6 acid and iron tetraoxysulfate 6. So it's like a test for the confirmation of the presence of trioxynitrate ion. Therefore, your answer is B. Next is question 32, which says a hydrocarbon has an empirical formula CH and a vapor density of 39. Determine its molecular formula. Usually, in the determination of the molecular formula of a compound, you use your empirical formula along with your molecular weight. Here we're not given molecular weight, but we're given vapor density of 39. You can simply then get your molecular weight as Vd, that's your vapor density multiplied by 2. So you say your molecular weight is equal to 39 times 2, which will give you 78. Then you are given your empirical formula as CH. Of course, your C carbon is 12 gram per mole, and your hydrogen is 1 gram per mole. So for you to get your molecular formula, you simply substitute these values and divide. Since you are looking for the number of times, or the number of carbon atoms and the number of hydrogen atoms in this particular compound, this implies that you have an unknown value, x, and then you have your mass of carbon and your mass of hydrogen. Then when you multiply that value of this with your respective masses, it's supposed to give you 78. So here when you add 12 and 1, it will give you 13. When you multiply by your value of x, it's 13x, which will give you equal to 78. The reason why you are only adding one value of 12 and one value of 1 is because we only have one carbon and one hydrogen. It will be a different story if we have C2H or CH2 or something like that. For example, if it were CH2, you have 12 plus 1 plus 1. Anyway, to find your x here, you divide both sides by 13. So you have x is equal to, you divide 78 by 13, and that will give you 6. So you multiply 6 by C and H. This implies that your multiple is 6. So when you have 6 CH, of course it will give you C6H6. That's benzene, right? So your answer here is C6H6. That's D. The next question is, which of the following is used as a rocket fuel? You have A H2SO4, B HCl, C HNO3, and D CH3COOH. The answer to this question is HNO3, and that's because there's a particular red fuming nitric acid, also called RFNA, which has HNO3 as its 4% of its composition. Therefore, you can say that HNO3 is often used as a rocket fuel. Next is question 34. Question 34 says, the petroleum fraction that is used in heating furnaces and industries is A. Diesel oil, B. Gasoline, C. Kerosene, D. Lubricating oil. Of course, it's not lubricating oil, and of course, it's not kerosene. And gasoline refers to petrol, which is not used in heating furnaces and industries. So our answer is A. Diesel oil. Then the next is question 35, which says a constituent common to bronze and solder is A. Copper, B. Tin, C. Lead, and D. Silver. You can recall that bronze is actually an alloy that is made up of copper and tin, and also solder is also has tin as part of its constituents. So your answer is B. Tin. The next question is question 36, which says, when iron is exposed to moist air, it gradually rusts. This is due to the formation of A. Anhydrous iron 2 oxide, B. Hydrated iron 2 oxide, C. Hydrated iron 3 oxide, D. Anhydrous iron 3 oxide. So remember that the conditions that lead to the rusting of iron are the presence of oxygen. And so when iron 2 is actually exposed to the moist atmosphere, it becomes hydrated and also oxidized to iron 3 oxide. Therefore, your answer is C. Hydrated iron 3 oxide. The next question is question 37, Question 37 says a compound gives an orange-red color to a non-luminous flame. This compound is likely to contain A ion 3, B ion 2, C sodium ion, and D calcium cation. So this is actually testing you on your knowledge of flame tests. And actually, when a compound gives an orange-red color to a non-luminous flame, it's indicating that there's a presence of calcium. Therefore, your answer is D. Next is the 38th question. It says stainless steel is used for making A. coins and medals, B. moving parts of clocks, C. magnets, D. tools. Actually, stainless steel, due to its peculiarities, is used to make durable substances, among which are tools and cutlery. So your answer is D. tools. Then next we have question 39, which says polystyrene is widely used as packaging material for fragile objects during transportation because of its A. lightness, B. low density, C. high density, and D. high compressibility. So the answer is high compressibility because remember, if you notice that in the question we were specifically asked why polystyrene is used for packaging fragile products. And fragile objects are usually prevented or protected against damage due to maybe falling down or being squished and stuff like that. So the compressibility characteristic of polystyrene makes it a wise choice when packaging fragile objects, because even when it falls, it gives it a protective shield. So your answer is D. Next is question 40, which says the IUPAC nomenclature of the compound above is A. 5-propylheptane, B. 3-propylheptane, C. 4-ethyl-heptane, and D. 5-ethyl-heptane. Now you can recall that in the naming of organic compounds, you take note of the position of your substituent. Also, you start naming from the smallest position, either from the left or the right, but you start naming from the side that gives you the lowest number when you are counting the position of your substituent. So for this now, if you were to expand this, we have one carbon here and then 3 carbons here, as you can see from the CH2 before the carbon having the substituent of propyl. Propyl refers to the alkyl group with 3 carbon atoms before having 2 carbons afterwards. So the proper way to name this compound is starting from right to left, because that will give us the substituent on carbon 3. Hence, your answer will be 3-propyl, and then you now take a look at how many carbons are in the longest chain. So we have 1 plus 3 here, given 4, then 5, and then 2 here, we have 7. So you have heptane having a propyl group on the 3rd carbon atom. Therefore, your answer is 3-propylheptane. So your answer is B. With this, we've come to the end of this session. Good luck on your exams and do well to check all the relevant topics contained in your syllabus. Wishing you the best of success in your exams. Thank you for your attention.